Hello, I'm Mr. Charlie, and welcome back to Physics A, Lesson 2, Vectors, Exponents, and Graphing. Last lesson we talked about a quick physics review, a mathematics review of primarily algebra and trigonometry. We also talked about units a lot, how we use the standard international system of the scientific notation, and that's composed of 7 base units, for example, meters, kilometers, seconds, and Kelvin. And you combine these base meters into derived meters, derived units that we will use to measure most of the quantities that we're going to be concerned about in Physics A. So if you somehow missed that lesson and you feel weak in trigonometry or algebra, I recommend reviewing that on your own, since we already covered that here. For trigonometry, you don't need to worry about a lot of like graphing inverses and figuring out reference angles and all of that other stuff. And the identity is really all that's going to matter is that you know the definitions of sine, cosine, and tangent and can use them to solve for the missing side or the missing angle in a right triangle. And pretty much right triangles are going to be what we're mostly concerned with here as well. So don't worry too much about law of sines and law of cosines. That's going to be water under the bridge. So today, vectors, exponents, and graphing. So again, start with the word that I did not put up there, scalars. Any discussion of vectors must begin with a discussion of scalars. Why? Because you already know everything about a scalar. You are infinitely familiar with scalars. So that being said, what is a scalar? A scalar is the opposite of a vector. I'm sorry, that's a terrible answer, because you don't know what a vector is yet. So a scalar is just a fancy name for a regular number. 1, 2, 5, 10, -3. These are just scalars. They have only a magnitude and no direction. Magnitude means size, so the magnitude of 1 is 1, magnitude of 5 is 5, and so this is pretty easy. This means the size. So again, in physics, just like in math, they behave just like they always have in regular numbers. They obey, in algebra, they obey the commutative property, A plus B equals B plus C. The associative property, A plus C plus B equals A plus. You can group them however you want. So they're regular numbers, and you don't have to worry about their behaviors at all, because you already know how to use them. So just keep on doing your thing, and everything will be just fine. So what are scalars good for? Why do we call them scalars? Why do we care about the distinction between vectors and scalars? Scalars are good for measuring things that have no direction associated with them. For example, mass is 5 kilograms. I weigh 82 kilograms. I don't weigh 82 kilograms down or left. It's position independent. It doesn't care which direction I'm going. I just weigh 82 kilograms. Same thing with energy, time. If time doesn't go backwards, it's like 5 seconds. It's not -5 seconds. That doesn't make sense. Distance and speed. These are all units that have no direction. So that brings us to quantities that do have direction, which are represented by vectors. So what is a vector? Well, a vector is the opposite of a scalar. If a scalar has only magnitude but not direction, then if a scalar has only magnitude but not direction, then a vector has both magnitude and direction. It's represented by an arrow. It's a mathematical object that represents a number. That number is given by its length. I'll call that, if this is vector v, this is v for vector, I'll call this quantity here its magnitude v. Using the absolute value sign, since absolute value sign basically means the magnitude of a scalar. So its length is its magnitude or its size, and it has a direction given by the direction in which it's pointing. You could say northeast. You could say, in this case, 45 degrees.